In section 5 now of chapter 5, operations with radicals. So keeping our flipped classroom video in mind, now what would this be if we took the square root of 16? That would be 4. And we have 4 decimals, so there would have been 2 decimals there to square this. If we squared this, it would be this. So the square root of this is this. And if you put that in your calculator, you would have verification. All right, now we said in our lesson that this answer is going to be negative. And we could write it the square root of 81 over the square root of 4. 81 is a perfect square, so this, I'll write it over here where we get a little more room. It's going to be a negative 9 halves. All right, so we're starting off easy. Now, one of the other rules that we had was that we can multiply radicands, and this would be the square root of 18. But notice something. If we tease this apart here, this is the square root of 3, and 6 would be the square root of 3 times the square root of 2. 2 times 3 is 6. But if we combine these two, this is the square root of 9 times the square root of 2. The square root of 9 is 3. Talk about saying something and writing something else down. The square root of 2. Now another way of looking at this would be, this is the square root of 9 times the square root of 2, which is what we have here. So 18 forever and ever now will be, if we had to simplify it, 3 the square root of 2. All right. Now, as we go into example 4, and if we were to give you an essay question, what is the protocol or procedure for simplifying a radical? Well, the procedure would be that under the radical sign, the radicand could not contain any perfect square factor. So as we look at 45, we wonder, is there, and the protocol was to do 2 sets of parentheses. And under one parenthesis is to put the largest perfect square factor we can take out of 45. And what would that be? Well, that would be a 9. 9 times 5. So now the square root of 9 is 3, and we have the square root of 5. So we've taken the radicand, teased it apart into the largest perfect square factor under one radical sign, and whatever factor is left under the other radical sign, taken the square root of that, and then this is now in simplified form, because what is under the radical sign no longer has any perfect square factors. Well, put that into an essay, probably clean it up a little bit. Let's go on to number 5. Now, we're looking at the square root of 130. This would be less than something here, and that would be greater than something here. So they're asking for integers. So what would be the next perfect square above 130? And if you're thinking 144, that would be good. And that is 12. So the next perfect square below that would be less than 12 would be 11, and the 11 squared is 121. So the square root of 121 is 11. So by thinking of consecutive integers, the square root of 130 falls between the integer 12 and the integer 11 using this methodology. And if you're not sure about something, be sure you ask. Now in number 6, this is the original example. And what I've done is we have to simplify each of these radicals using this process we spoke about. And then we're going to do some calculation. But let's see if you can get this stage done. So here we would have 4 times 2 is 8. 9 times 2 is 16. 18. I don't know where I got that from. Here I'm thinking this one. This is 16 times 2. So now the part that's left over is the square root of 2. And we're going to get what is called like radicals. So next step would be to convert the square root of 4 into a 2. So this is 4 times 2 is 8, the square root of 2. Convert the square root of 9 into a 3. 3 times a negative 3 is a negative 9, the square root of 2. And the square root of 16 is 4. 3 times 4 is 12, the square root of 2. Now we have like radical signs. We just use their coefficient in the sense. 8 and 12 is 20. Minus 9 is 11, the square root of 2 for this answer. And again, you're going to be doing practice and certify, and this is from the practice. Now, in this next part, we're asked to rationalize the denominator. Well, as we mentioned in our flipped classroom video, when you have a radical that's in the denominator, they don't usually like that there. They want you to get rid of that radical. Well, how do you do that? Well, by taking a radical and making it rationalized. This is irrational as we see it. To make it rational, we have to make this something without the radical sign. Now, one of the most common ways to do it is to multiply a fraction, and we did this before, by 1. Now, the fraction we're going to use here is the square root of 13 over the square root of 13. Now, whenever you have 13 times 13, this is going to square this so that our denominator now becomes the square root of 169, which is 13. We have rationalized the denominator. But now our numerator becomes 6, the square root of 13. So they gave us sort of an easy one. But this one is like super easy. What would this be? Well, this is negative square root of 4. Square root of 4 is 2, so it's negative 2. So that's a real easy one here. Now, for this one, I'm going to ask you to do something a little different too. I would like you to simplify this before we put it in our calculator. And the protocol would be to divide that into two parts. All right, so this is going to be 4, and this will be 3. Now the square root of 4 is 2. 2 times 4 is 8. The cube root of 3. So I'd like you to put this in your calculator to get an approximation. And then later this in your calculator to get an approximation. And let's see what you get. Well, when I did it for the same, came out the same. It was 13.85640. And they want you to round to the nearest 10,000ths. Well, this is units. I should say tenths, hundredths, thousands, 10,000ths. So we'd go to the 5th place. It's a 0 that we're going to drop. And then this is what our answer would be. Now, if you did it this way, that's the answer. If you did it this way, that's the answer. But this one is in simplified form because under the radical sign, there is no longer any perfect square factor. Again, that might be a good essay question. How do we simplify radicals? Now, for number 10, this was a little hard to read. And there's the formula they're giving us, and this symbol here is pi. So as we do it and substitute these values into our radical sign, notice that the pi's cancel out. So when we divide 16 into 768, we get r equals the square root of 48. But they want that answer in simplified radical form. So I'll let you folks have a chance to work on that since you haven't had that many opportunities, and let's see what you get. So this is 16 times 3, which will be 4, the square root of 3. That is what the radius would be for this can that they're going to put some mixed party things in. What we're going to do for number 11, I had done something else last time. I'm going to redo this. And again, we want to simplify. And as we simplify, we cannot have a radical in the denominator. So as we go to rationalize our denominator, our numerator is the square root of 6 that I'm going to write as the square root of 2 times the square root of 3. Now my denominator I'm going to write as the square root of 7 times the square root of 3. So hopefully you can see what I've done. I've teased apart the radicands to their common factors in a sense. Now, what do you see here? Well, there's the square root of 3 divided by the square root of 3. So this is a 1. So through the magic of an eraser, I'm going to take this out of there. And now this is what I have to rationalize. So it's much easier. Now we will take the fraction and we'll multiply it by the square. Let me change colors too. The square root of 7 over the square root of 7. So what is this? Well, this is a 1. But now we get the square root of 14 over the square root of 49, which is 7. And there's my answer. When I did this the other way, it was very complicated. This is a much better protocol here. Two-term radicals, and we're multiplying it. And you might say, well, what method would we use? Well, you're going to use the FOIL. And I'll write it out for you, and you can kind of follow along with me. We're going to multiply this by this. Now, the square root of 3 times the square root of 3 is the square root of 9, which is 3. 5 times 4, and I'll put it this way, 20 times 3 is what this becomes. 4 times 5 is 20. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Now we're going to do our outers. It's going to be a negative 4 times 5, a negative 20. The square root of 3 times 5 is 15. So once again, the outers, 4 times a negative 5 is a negative 20. Square root of 3 times the square root of 5, square root of 15. Now we're going to do our inners. Now there's a 1 there that we don't write. So negative 1 times 5 is a negative 5. Square root of 5 times the square root of 3 is the square root of 15. All right, now our last. This is a negative times a negative is going to give us a positive 5. Now, the square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is 5. Now, we do this. This is going to be 60. This, we have like radicals, so we're just going to add our terms. This is a negative 25, the square root of 15. Now, this is going to be a positive 25. 25 and 60 is 85 minus 25, the square root of 15. Wow. Now I can say you're not going to have any like this on your test. You might have one as just a challenge here on your practice and certify. Again, this is from the practice. All right, this will wind us up. And again, as we say, if you need to watch this again, it is available. And of course, we did a lot of this in the flipped classroom video.